A measure of how much the linear correlation between x and y actually affects the value of y is r squared. The value of r squared is the proportion of the variation in y that is explained by the linear relationship between x and y. So the calculator will provide r squared for us, but it should be understood that it is just that linear correlation coefficient r raised to the second power. That's exactly what it is, r squared. So let's look at an example. Just say, for example, we worked the problem I mentioned before. Say we had all this ordered pairs in a sample, and the x values were the amount of sunlight that a plant received, and the y values were the height of the plant. And say we calculated an R test statistic of 0.967. Okay, so our R squared then would be this 0.967 squared. This is, the calculator will give this to you, but this is what it's doing. And that's 0.935. So, from this we would conclude that 93.5% of the variation in plant height, so let me write that, 93.5% of the variation in plant height and this is my y, can be explained by the linear relationship. Between the amount of sunlight exposure and plant height. And this is our x, the amount of sunlight exposure, and plant height. And that was our y. So what this means then is that 6.5%, the other 100%, the other portion of the 100%, 6.5% of the variation in plant height cannot be explained by the amount of sunlight exposure and its relationship to plant height. And it's due to some other variables or to random variation, something we didn't study, like I mentioned before, something to do with the soil or seeds or something else that's contributing to plant height. 6.5% coming from somewhere else, but this is quite a bit. 93.5% of the variation in the height of the plant is due to this linear relationship between the amount of sunlight exposure and plant height, r squared. So this is a measure of how much the linear correlation between x and y actually affects the value of y.